So, in this session, we're gonna talk about a new topic, arrays. So, uh, arrays are one of the most useful ideas in programming. Once you understand arrays, you can handle way more data without writing the same code over and over again. To start simple, an array is basically a group of variables of the same type, like a line of boxes that all hold the same kind of thing. Imagine you're tracking five-player scores in a game. Without arrays, you might have five separate variables like score 1, score 2, score 3, or so on. That gets messy fast. So instead, with an array, you can store all of them together in one container and just use an index number to get to each one. So picture this like a row of boxes, each one labeled with numbers starting at 0. That's important. Arrays in Java always start counting from 0. So if you have 5 elements, the first index is the first one is index 0, and the last one will be index 4. So this 0 based numbering trips people up at first, but once you get used to it, it'll make sense. So let's say you got this array called scores. So scores 0 is the first score, scores 1 is the second, and so on. So the little number in the brackets is called the index. That's how you uh, access or update a specific elements in an array. So now what's cool about arrays is that they make it easy to do things in loops. So you can loop through the entire array to print all the scores and calculate an average or find the highest scores, all with just a few lines of code. So that's what we'll be doing a lot in this topic. So you'll also see arrays used everywhere, like in bank apps, store transactions, or in simulations to handle large data sets. Basically, whenever you find yourself creating a bunch of similar variables, that's a sign you probably need an array. So now there's a one common mistake that catches everyone. The number of elements in an array isn't the same as the last index. So if you make an array of size 5, the indexes go from 0 to 4. So if you try to access like something like scores bracket 5, Java will throw an error because the index doesn't exist. So always check the last index is 1 less than the total number of elements. That's the core idea. Arrays help you store, organize, access multiple values efficiently. In the next sections, we'll look how to actually create them, initialize them, loop them in code. So yeah, that's about the general idea of arrays. So now that you know what an array is, let's talk about how to actually create and use one in Java. So when you think about arrays, remember this: an array is just a group of slots in memory. So each ready to hold one value of the same type, like a storage shelf with numbered compartments. So let's start with the beginning, from the beginning. So declaring and allocating an array. So when you declare an array, you're telling Java, hey, I want a list of values of this type. So for example, if you want array of integers, and you write something like so you would write something like int numbers. So that's declaration part. But at that point, you don't actually have any space yet. It's just a variable that could point to an array. To actually give it space, you allocate it with a new keyword like like this, new int. Now that creates room for 5 integers, all initialized to 0. You can do both steps together, declare and allocate in one line. That's what you'll usually see in practice. So this is how it looks. But now you've got 5 slots labeled 0 through 4, each ready to hold an integer. You can also initialize an array right away with values. That's called literal initialization. For example, something like 1, 1, 3, something like this. This is really handy when you already know the values you want to store, like test scores or constants. So something like uh, let's say int scores. Let's give it decent numbers. So that's a 3 element array with those exact values already inside. So now an important thing to remember is, remember all arrays in Java are fixed in size. Once you decide how many elements an array will hold, that number can't change. So if you want something that grows or shrinks, that's where other structures like array list come in, but that's for later. So when you're working with arrays, Java gives you a super helpful, useful property called dot length. You can use array name dot length to find out how many elements it has. That means you don't need to hard code numbers like 5 or 10 into your loops. For example, if your array grows or changes later, your array still works correctly. It always knows how many elements are there. And one thing to avoid is if you try to access an element that doesn't exist, like you know, number index 5 in an 5 element array, Java will throw index out of bounds exception. That means you went past the edge of your array, like trying to grab a box that isn't actually on the shelf. So whenever you're looping through arrays or accessing elements, always double check that your indexes uh, go from 0 up to array.length -1. uh, so yeah, this section is all about getting comfortable building arrays and understanding how they live in memory. So once that clicks, the rest, like looping through or modifying them, will feel much easier. So that's about creating and using arrays. Next we have array iteration drill. So now that we've talked about how to create and use arrays, it's time to look at how we actually work with them. That means loops. uh, Arrays and loops go hand in hand. If an array is a row of boxes, a loop is how you walk down that row, checking or changing each one by one. So now there are two main ways we loop through arrays in Java: for loop and for each loop, and both have their own purpose. Let's start with for loop. The classic for loop is your go-to when you need to use the index, maybe to track position or modify specific elements or look at neighboring values. So it's like saying, I want to go through the list from first element, which is index 0, to the last element, last one, and you usually use arrays dot length property, so the loop automatically adjusts if size changes later. This loop gives you a lot of control. You know exactly which element you're on, and you can easily say things like only update the even positions, or stop at certain index. uh, so whenever you need the index itself, this is the right loop to use. And next we have for each loop, so also called as enhanced for loop. It's a bit simpler and cleaner when you just care about the values, not their positions. So it's basically It basically says go through each element in this array and do something with it. So it's great for printing all the elements, adding them up, or checking if something matches. For example, if you had a array of test scores and you just want to find a total, or a for each loop would let you go through every score without worrying about index numbers. Now here's something important to keep in mind. With for each loop, you're working with a copy of each element's value and not a direct reference to the array slot itself. So if you try to modify the element inside a for each loop, it won't actually change the array. Uh, and that's really a uh, common pitfall to run into. So if you want to update or replace values inside the array, use regular for loop instead. If you just want to read or process values like printing, summing, counting, then for each loop is perfect. Yeah, you'll be working uh, these in your Zybooks, so you'll get a better understanding then. So yeah, loops are one of the most powerful tools you'll use in arrays, and once this clicks, you'll start to see patterns everywhere, like summing data, finding the largest value, searching for matches. It all comes down to looping. So take your time on this, experiment, print values out, see how both loop types behave differently. That's the more you practice, the more natural it feels. uh, Next we have iterating through through arrays. So now that we talked about basic loops through arrays, let's take things a little further. So in this section, we're going to look at different ways to iterate through loops, not just straight from start to finish, but also in reverse, like skipping elements or performing checks as we go. So far we've been looping through each element one by one, but in real world problems often need more control. For example, maybe you want to find the highest score, or count how many items meet a certain condition, or even process the array backwards. So let's start with the idea of reverse order. So you don't always have to start from index 0. Sometimes it makes sense to start from the end and work your way backward. For example, imagine you are displaying a list of recent messages. You might want to start with the newest one at the end of the array. To do that, you just flip your loop direction. So instead of counting up, you count down from last index to 0. That's for reverse order. Next, we can skip elements while iterating. Maybe you only care about every other element, every other value, like summing just the even positions or processing data in pairs. In that case, you can adjust your loop so it jumps by 2 each time instead of 1. So it's a small trick, but super useful when your data has patterns. And then there's conditional processing. So probably the most common use of array iteration. That's when you use an if statement inside your loop to check something about each element. For example, count how many numbers are above 80, or find all elements that match a specific keyword. This is how you filter data or collect statistics from your array. Some classic example you'll see over and over is finding the minimum or maximum value in an array, counting matches like how many students passed, uh, computing an average by summing everything and dividing by the number of elements. These patterns show up constantly in data analysis. Yeah, many things. Now, one skill that will really help get better with arrays is debugging with print statements. So if your loop isn't behaving like you expect, maybe it's skipping something or going one too far, print the index and value each time the loop runs, and seeing the output step by step makes it much easier to understand what's going wrong. Uh, Later, when you move into more advanced debugging, you'll see breakpoints in your IDE to pause your program and inspect variables in real time. So yeah, these are simple techniques. These simple techniques are the foundation for everything, for sorting algorithm to AI loops. Uh, Once you can control how and when a loop moves through an array, you can do just about anything with your data. All right, that's about this topic. Yeah, okay. Next, we have multiple arrays. Let's talk about something a little more advanced with arrays, using multiple arrays together. So far, we've been looking with single arrays, one list that holds one kind of value, like all test scores or all prizes. But in real world programs, data comes in pairs or sets. For example, if you're tracking students and the grades, you need both. So a student's name and their score. That's where parallel arrays come in. Parallel arrays are two or more arrays that are linked by their index. So the value at index 0 is one array, corresponds to the value of the at index 0 in another. So let's say you have an array called students, another called grades. So at index 0, students might be Alex, and at index for grade 0 might be 95, and at index 1, student is Jordan, and grades index 1 is 88. So those two arrays are connected position by position, like two matching lists that describe one set of data. This approach is actually super common in early programming. It's simple and gets the job done when you're not using more advanced features like objects or classes yet. In fact, data tools simulations use these approaches behind the scenes to keep different pieces of information in sync. So now there's one big rule when you're using multiple arrays. They have to stay the same length. If one array is shorter or longer than the other, your indexes won't line up anymore and you'll start pulling the wrong data together. That could lead to weird bugs like displaying the wrong grade for wrong student. A good habit is to base all your loops on one array's length, usually the one that drives the data, like students array. Then use that same index to access the linked value in the other array. So later when you move into classes and objects, you'll see that this idea grouping related data together becomes a lot cleaner. So instead of using two separate arrays, you will make a single student object that has both name and grade. But for now, using parallel arrays is great way to think that direction and understand how data relationships work. So as you go through Cyberbook activities, focus on how indexes relate. When one changes and the other should move with it. Try adding print statements to confirm that data lines up correctly. So once you get this pattern, you'll start seeing it everywhere. Anytime you have data that naturally belongs together. That's about for today's topic. We'll discuss the rest of the topics in the next session.